Hello and welcome to another Ginger Mathematician video. Today we're going to go through all things A-Level Maths Paper 1 functions. And this really carries on quite nicely from iGCSE functions. So if you've done either of the iGCSE courses, then this will fit very nicely in. With algebra, it gets a little bit more difficult and it really tests your understanding. Right, let's get started with question 6 here, and the function is defined as follows. So f of x is equal to x squared minus 4 divided by x squared plus 4, and this is important later on that x is greater than 2. So keep that in mind when we do part C. And the first thing we need to do is find an expression for the inverse. As soon as we see this minus 1 here, it indicates we need to find an inverse function. And if you've seen my iGCSE videos, you know you've got this 3-step procedure to do it. So number 1 is to make this function equal to y. So x squared minus 4, x squared plus 4. Step 2 is we're going to switch over the x's and y's. So we're going to have an x here where we had a y, and these x's will then become y's. And it's a standard procedure. And then our task here, which is the tricky part of the question, is making y the subject. And they'll often, on these A-Level Maths Paper 1 questions, give you a fraction or a rational function to work with. So our first step will be to remove this denominator. So we're going to multiply by y squared plus 4 on both sides of the equation. This cancels, leaving us just y squared minus 4 on the right hand side, and then on the left hand side we get x bracket y squared plus 4. Then we're going to expand the bracket out using the hook. So we get x times y squared is xy squared, 4 times x is 4x, leaving the right hand side alone for the time being. And now this is the crucial step that most students forget, or at least these two steps. Get everything with y on the left hand side, anything else on the right hand side. So what I'm going to do is I'm going to minus y squared from both sides, and I'm going to minus 4x from both sides. So if I do that, we then get xy squared minus y squared is equal then to minus 4 minus 4x. To try and speed up the process, you'll know in the iGCSE video I did this in 1 step, or 2 steps. Now I'm doing it in 1 step instead. And this is the second step that people often forget, which is we're going to factor out this factor of y. So we're going to have y squared outside and then work backwards. So what do you multiply y squared by to get xy squared? That's going to be x. What do you multiply y squared to get minus y squared? That's just minus 1. And keeping this the same over here. And now all we need to do is then divide through by this factor. So we're going to divide by x minus 1 on both sides. That then gives us y squared, so this cancels, is equal to minus 4 minus 4x over x minus 1. And we can be a little bit sneaky here. We can actually switch over all the signs. So what I'm doing essentially here is I'm just taking this fraction and timesing minus 1 at the top and minus 1 at the bottom. That doesn't actually change what it is. The effect that this has is this becomes positive, this becomes positive, and we switch the signs here. Again, working with positives makes things a little bit easier for us. If you left it like this is absolutely fine. However, we haven't finished the question because we have a y squared here. So to get y, we then need the square root of this function over 1 minus x. So there we are, and then all we do, just to make sure we're answering the question that they give us, is the inverse function is then equal to the square root of 4x plus 4 over 1 minus x. We're going to do a ton of practice with inverse functions because it comes up a lot on the paper 1. So you do need to know how to get to this answer that I've put in the box at the bottom. Okay, and now this is quite a typical style question where they want you to change the function slightly so you can say something about the domain or range. So first of all, we need to show that this is equal to this. So what we're going to do is we'll start with 1 minus 8 over x squared plus 4. Now generally the pattern here is you look at the denominator, so you look at the x squared plus 4, and you want to change the 1 in terms of x squared plus 4. So all we're going to do, very sneaky, we're going to write x squared plus 4 divided by x squared plus 4, because if you cancel that through, that will just give you 1. And now we have the same denominator for both fractions, so we can just combine them. So we get x squared plus 4 minus 8 over x squared plus 4, just adding fractions here, and then this gives us x squared minus 4 on the top and x squared plus 4. Perfect. Right, and now using this fact, so using the idea that our original function, so this f function here, notice x is greater than 2, so we'll come back to that, is the same as this. Essentially what the question is asking, because they're using this word hence, they want you to state the range of f using this. So you want the range of this function. Now just to remind you what the range means, range is what y can be. And you're thinking, there's no y's here. Well, remember we can write the f function as equal to this. So 1 minus 8 over x squared plus 4. So we want to consider what y can be. Remember though, in the domain that we're given in the start of the question, x must be greater than 2. So my approach to this will be, first of all, let's look at what x equals to actually makes. So if we work out when x is equal to 2, and we pop this in, so we get 2 squared plus 4, so 1 minus 8 over 8. Okay, so that's going to give us 0. So one end of our range, because we've looked at the extreme case, is going to be 0. And now we need to think about, okay, what happens when x is less than 0? So say x is some very big negative number. So x was minus 100. Let's just think this through. If x is like minus 100, then minus 100 squared is going to give you a very large positive number. So essentially you're going to get a very, very big number on the bottom here. If you get a very, very big number at the bottom of a fraction, then that fraction is going to become 0. Imagine 1 over a million, for example, is going to be 0.0000001. It's going to be really, really small. So if this number gets very, very big, it doesn't matter if it's negative because this will become positive anyway, then this whole fraction then becomes 0. And if that whole fraction becomes 0, so as x goes to negative infinity, so it gets a very, very large negative number, this function y becomes essentially 1 minus 0, which is equal to 1. It never quite reaches it, but it gets very, very, very close. And now we've actually found the range of values, hence the word range, that, given the domain that we have, goes between. So our answer for the range is just going to be between 0 and 1. Notice we have strict inequality signs here because we have a strict inequality sign for this part, and as we go to infinity it never actually reaches 0, so it can't be less than or equal to. It's a nice question. It really does test your understanding of functions and how they work. Part C is also in that form, explaining why the composite function f, so I tend to write this as f of x, that's another way of writing it, can't be formed. So i.e., in other words, doesn't work. And I'm going to do this by a counterexample. So say we take something that is in our domain. So x must be greater than 2. So say we take f of 4 here. So if we work out f of 4, so we're just going to put 4 into this function. We get 4 squared minus 4 over 4 squared plus 4. That's equal then to 16 minus 4 is 12, and then 16 plus 4 is 20. So f of 4 is equal to 12 over 20, which is decimal. There's some of you love decimals out there. That's equal to 0.6. Now what I want to do, if I had a composite function, is actually try to work out f of 0.6. But that's not possible because x must be greater than 2. And notice this 0.6 is not greater than 2. So once you've worked out the f function, you can't take that answer. I've shown one example where you can't take it, and therefore it can't be formed. So one counterexample is more than enough to show that f of x can't actually be formed. Okay, so you can have a look through the mark scheme. It's a big mark scheme for these function questions. So this is 6a here. And then we have 6b and 6c going through the reasoning I've just said for this functions question. Hello, and on to question 10, which if it's double figures, you know it's going to be a bit more difficult. So we've got functions f and g here. F of x is 2x plus 1 over 2x minus 1, where x can't be a half, a rational function, and we have a quadratic for g of x. And the diagram above shows the graph of f of x, so our rational function, and we need to find the domain of the inverse of f. Remember, f to the power of minus 1, if you want to call it that, just means the inverse of f. I'm going to use a fact that's very important on the course, and we're going to use it again and again in this video, which is a domain of the inverse is the same as the range of the original function. So we want to find the range of f here. So remember, think about the range here, what y can be essentially. We're looking top and bottom, so we're looking up and down. And you can see basically be any value apart from this asymptote here. So I'm just going to draw in. Now you're probably happy enough to say, well, this asymptote is equal to y equals 1. It's just a horizontal line at 1. But we can actually work it out algebraically, which is useful for the A-level course a bit later on. And the way that we do this is we find the limits of the function as x goes to infinity. And the way that we do this is that any constants, i.e. this plus 1 and minus 1, don't really matter when the number gets really, really big. So then this then just simplifies down to 2x over 2x, which will give us 1. So that's another way of actually finding this asymptote here, which is very useful. And that's essentially all that we need to know. Remember to write x here because we are looking for a domain, so we're working with x. So the domain here is just x is any real number, but x can't be equal to 1. Again, 1 mark question. They're not going to expect you to do too much on this style of part A question. On to question B here, which is to find an expression for the inverse of f. A very common kind of question. So if we crack through this, so we have, first of all, y is equal to the function we have, which is 2x plus 1 over 2x minus 1. Remember that 3-stage procedure we're going to go through. Step 2 here, we swap the y's and x's over. So wherever I see a y, I put an x. Wherever I see an x, I put a y. It's very similar to a question we've already done. And now we want to make y the subject. So the way we're going to do that, first of all, we're going to multiply by the denominator on both sides. Again, make sure I write my working in. Let's pop it over here. So that means we get x lots of 2y minus 1 is equal to, well, this cancels, leaving us with just 2y plus 1. And remember this very, very important step once we've expanded the bracket here. So x times 2y is 2xy. X times minus 1 is minus x. Is we want everything with y on the left-hand side, anything else on the right-hand side. If you remember one thing from this video, that's important because it'll get you a couple of extra marks. So the way we're going to do this is we're going to add x on both sides and we're going to minus 2y from both sides, giving us what we want. So this cancels, leaving us then with just 2xy minus 2y. And then we've got a 2y and 2y cancel, giving us then x plus 1. Remember this very important step that I literally just mentioned 20 seconds ago, which you want to take out a factor of y. Now, how do we do this? Well, I do y, I set up my single bracket, and then work backwards. So what do you multiply y by to get 2xy? It's going to be 2x. What do you multiply y by to get minus 2y? That will be minus 2, equal to x plus 1. And then we're going to divide through now by this bracket. It's the reason we did this process. Divide through by the bracket. And that will then give us our answer, which is y is equal to x plus 1 over 2x plus 2. You could factorise the bottom into 2 bracket x plus 1. That's absolute 2x minus 1. Got to be careful when you do these things. So 2x minus 2. So you can factorise it at the bottom. That's absolutely fine. Just make sure when you write the answer at the end here, so f inverse is just equal to x plus 1 as a separate step over 2x minus 2. Okay, you could leave it as y, but I think it's more accurate just to write it. My inverse, this is what I'm looking for, is equal to that fraction. But you'll still get all 3 marks. From there, they want you now to work out a composite function. Now remember with composite functions, so we've got a function of a function, essentially. You work from right to left. So first of all, we want to work out the inverse at 3. So wherever I see an x, I'm going to put a 3 in the function we just worked out. So we get 3 plus 1 over 2 lots of 3 minus 2. That then gives us 4 over 6 minus 2. That's going to give us 1. And now we've got that answer. We now will put that into the g function. So we work out g of 1. Remind myself what g is here, x squared plus 4. So wherever I see an x, I'm going to put a 1. So 1 squared plus 4. And that's equal to 5. Again, use the amount of marks to sort of guide you how much work there'll be in the question. A 2-mark question and not expecting too much working here. Now on to question D, which I thought was a very interesting one. Explain why the inverse of G cannot be found. And this is interesting because we're going to see this in another question, a similar idea. So first of all, G of x is equal to x squared plus 4. Now, if you worked out the inverse of this in the same process that we did before, what you're going to get, so G inverse of x will be a square root function of some kind. Now, why is that kind of a square root expression, I should say? Now, why is that essentially a problem here? Because if I draw a square root function, so something that looks like this, notice that it's not actually a function. I shouldn't say the word function here, because if we do the vertical line test, which I'm hoping you've done on the course, you'll see then the vertical line test shows that we have a many-to-one function. Let me write that in. And what I mean by that is for every vertical line that I draw, almost every vertical line, I have 2 solutions, and therefore that means it is not a function. So the key thing to look out for is this phrase many-to-one, okay, or in other words, not a one-to-one function. Okay, it's not one thing in the domain that maps to one thing in the range, and because of that, the inverse of G cannot be found. Okay, question E here. So first of all, we've got to show that question, which we've seen in the previous part. From that, we're going to work out the area of the triangle enclosed by the tangent to the curve, y equals f of x, okay, at the point where x is 1, and then the x and y axes. So even though this is a functions video, we have got some differentiation in here as well, which is fantastic. So before we get stuck into that, we're going to show that this is equal to this. Now we've seen this process already. All we do is be a little bit sneaky here. We look at the bottom, the denominator here, 2x minus 1, and then we change the 1 into 2x minus 1 over 2x minus 1. Because if I cancelled that through, that would give me 1. So we've seen this idea in a previous question. Yeah, it's coming up again and again. This is why these videos are so useful. Once I've got a common denominator here, I can just add the tops. So I get 2x minus 1 plus 2 over 2x minus 1. And then that gives me 2x plus 1 over 2x minus 1. So a quick show that question here, showing that that expression here is equal to this expression here. Now we've got this lovely word hence, so we have to use this expression in some way. And as soon as I see the phrase tangent to the curve, Remember, f of x is equal to this 2x plus 1 over 2x minus 1. I'm thinking differentiation. I'm using these trigger phrases to get me doing that right process. So, f of x, now we've actually worked this out, can be equal to 1 plus 2 over 2x minus 1. And what we want to do is differentiate this. Now, before I do that, I'm just going to do a little bit of rearranging here, because we can think of this as 2x minus 1 to the power of 1 in the denominator, and therefore we can rewrite this as 2 brackets 2x minus 1 to the power of minus 1. Indices are really, really important when it comes to differentiation, and this is no exception here as well. Once we've got it written in that form, then we can use our chain rule to do some differentiation. So, first of all, if we differentiate 1, that's going to disappear. And this is now the tricky part, working with the bracket. But let's take our time and work our way through. First of all, we take the minus 1, bring it to the front. So we get minus 1 times 2 times the derivative of what's inside the bracket. Well, the derivative of 2x minus 1 is just 2. Then we copy our bracket and reduce the index by 1. So minus 1 is equal here to minus 2. If we simplify this down, so 2 times 2 is 4, 4 times minus 1 is minus 4, and we now get an expression for derivative using that handy show that part of the question. Hence, we're using the word hence. Once we've got that, then we go back to the question. We want to find the tangent to the curve at x equals 1. So, when x is equal to 1, the derivative minus 4, 2 lots of 1 minus 1 to the power of minus 2. Okay, so 2 times 1 is 2, 2 minus 1 is 1. 1 to the power of minus 2 is just 1, so we get minus 4 times 1, and we get minus 4. So what's this actually saying for us? What does this minus 4 mean? It means the gradient at that point. That's what we're talking about. Now, what does that look like visually? So let's go back to the question. So at 1, which is here, let's use a different color. What we're saying is there is a gradient, like so. It's not the best drawing in the world. Hopefully you see the idea. That goes through that particular point. Now notice it crosses the x-axis around about here. We're going to find out what that is, and up here somewhere as well. And what it's asking for, it wants us to work out the triangle formed by where it cuts the x and y-axis. So essentially this triangle, I'm not very well drawing in here. Remember, it's the right angle triangle. Now, how do we find where it crosses the y-axis and the x-axis? That is a good question. So, before we can do anything here, we need to find the equation of that line, the coordinate geometry in here. So therefore, we know the gradient is minus 4, so we can write it as minus 4x plus c. And now we can actually use our diagram here, because notice it crosses here at 1, 3. So if we substitute that in, so when x is equal to 1, y is equal to 3, we then get 3 is equal to minus 4 plus c, and therefore c is equal to 7. So this line, let's pop it over here, has the equation y equals minus 4x plus 7. Now remember, this plus 7 from coordinate geometry, this means the y-intercept. So that works out one of them for us, which is very useful. So we know it crosses up here at 7. The trickier part is working out where it crosses here. Now it's not at 2, even though my diagram is very close to 2, but it's not exactly 2. The way that we work this out is we set y to 0. This is a standard way to find a root or an x-intercept. So therefore, we get minus 4x plus 7 is 0. 4x is equal to 7, and therefore x is 7 over 4. For you decimal people out there, 1.75. So you can see why my diagram, it looks so close to 2, but be careful, it's not actually equal to 2. Now, finally, we actually want to find the area of that triangle. Okay, well, that's fairly straightforward. We don't need to do anything complicated with integration here. If we know that this is 7 over 4, we know then the height here is equal to 7. Then we just do half base times height. So we just go 7 times 7 over 4 and times a half. And if we simplify this down, we get 49 at the top over 8, which is our final answer for all 6 marks. Okay, check your workings so you can have a look at everything that I've done so far in this video. Again, looking for this idea of many to one or not one to one. That's what we're looking for that B1 mark. Again, it's a bit like in science exams, looking for that very specific phrase for that 1 mark. And then we've got question 10e here, where we get our final answer of 49 over 8. Okay, and on to question 6. So the function here f is defined by this quadratic, so fx is equal to 2x squared minus 16x plus 23. And very important for later in the question is our domain here is x is less than 3. And we'll see that in part B, exactly why that's important. The first thing we need to do, however, is express it in this particular form. So 2 brackets x plus a all squared plus b. This is known as completing the square. Unlike the iGCSE videos that I've done, there's a lot of crossover in the A-level course between different topics. So for example, I've done a video on quadratics. Again, I would check that out. If you just go to my playlist, you'll find it there. And it's really important that you can apply those techniques, like completing the square, also to a functions question as well. So let's get started with putting it in this form. So let's copy out the function and put it in completing the square form. Essentially, it's a 3-step procedure here. Step 1 is to take a factor of 2 out. So we need to have this as just x squared on its own. So I'm just going to take a single factor of 2 out. What do you multiply 2 by to get minus 16? That would be minus 8. And again, here we can just leave it as a fraction. That's absolutely fine. Notice if I multiply that, 23 over 2 times 2 gives you that 23. Now we've got the 2 out the way, we can start our completing the square process. So the first thing we do is we look at the b term, divide it by 2. So that's equal to minus 4. And then we set up the following bracket, x minus 4 all squared. Now imagine I expand that normally over here to x minus 4 times x minus 4. And if you use the old double brackets, the FOIL, the double eyebrow, we get x squared minus 8x. And minus 4 times minus 4 is positive 16. We don't want positive 16 though, we want this plus 23 over 2. So the way that we can do this is we can just minus 16 and then we add on then what we want, which is the 23 over 2, like so. Looks a little bit messy at this point, but we're going to do a bit of tidying up. Notice 16 itself, it seems kind of basic, but it's a nice trick we see a lot, can be written as 32 over 2. So if I just continue this, leave everything alone for the time being, and just write minus 16 as minus 32 over 2. Notice I can then simplify this part here, because we have the same denominator. Notice all those fraction skills still very, very important. So we get this, minus 32 plus 23 is equal to minus 9 over 2. And now we re-multiply it out here. So we multiply essentially just a single bracket. This then gives us 2 brackets x minus 4 all squared. And this times this gives us minus 9. So we have it in that form, so a here is equal to minus 4 and b is equal to minus 9. Notice the benefit of using completing the square, although there are many other techniques that you can use, is you can actually read off the vertex, so in this case the minimum point, because we have a positive quadratic, and our vertex will be equal to 4 minus 9. That's actually going to be quite important when we look at the next question here. So it wants us to find the range of the function, so the range of f. And remember, the range essentially is what y can be. Now, as soon as I see this, I look at the domain that we have here. So we have x is less than 3. And I look at, say, a critical value. So what I mean by critical value is look at when x is equal to 3. So x is equal to 3. So if I put that into my function, so f of 3, and substitute it in here, again to either one here, because they're both the same thing, we get 2 brackets, 3 minus 4 all squared, minus 9. That's going to give us minus 1 all squared is 1, 1 times 2 is 2, 2 minus 9 is minus 7. So one value on our quadratic is 3 minus 7. It's going to help us a bit later on. Now if I was to draw a sketch using the vertex, so notice I've got the vertex here, so the minimum point. This is quite good to visualize how I get to the answer here, rather than just giving it to you straight away. If I draw this function out, we've got this 3 minus 7, which is down here somewhere. And we have the minimum point, which is 4 minus 9, which is a little bit further along. And because we have a positive quadratic, so 2x squared, we're going to get a function that looks something like this. So again, just so you can see what's going on, like this. However, we're not looking for the range of this entire function. We're only interested when x is less than 3. So we're only interested in this black part of the graph. So this is all we're interested in here. And then we want to think, well, what's the range of this function? Well, basically, we started from a y perspective, minus 7, and then we basically just go upwards and upwards and upwards. So our range here is going to be, I'll just write it here separately. It's a 1-mark question, so you can do it straight away. It's just y is greater than minus 7. Notice we have a strictly less than side, therefore this is a strictly greater than side. All the question is asking you to do, if I draw a quick sketch of the function here, what's the range? What can y be? Well, everything above minus 7. Okay, and you see it again. You're probably getting fed up already by seeing this. The question's asking us to work out the inverse of this particular function. Okay, this is a bit trickier than ones that we've seen before. Again, we like to use this form here. It's going to make our life a little bit easier. So it's one of the reasons you need to use previous parts of the question to help you. So we have 2 brackets x minus 4 all squared minus 9. And so we're going to go through our 3-step procedure with a little twist at the end. So we have y is equal to our function. Well, I wonder where the twist is. Well, you'll see in a moment. Number 2, we swap the x's and y's over. So we have x is equal to 2y minus 4 all squared minus 9. I tend to flip the equations, so I have y on the left-hand side ready to work with. And now we need to make y the subject. So first of all, I'm going to add 9 on both sides. That gives me then 2y minus 4 all squared is equal to x plus 9. And we divide through by 2. Again, get lots of practice at this. It comes up a ton. Then we're going to square root the functions. The opposite of squaring is square rooting, so we have to be careful. So we get y minus 4 is equal to plus minus the square root. Remember, if you're square rooting, you have a plus and a minus. And then we're going to add 4. So we get y is equal to 4 plus minus square root of x plus 9 over 2. So that is our inverse function, but probably what you've noticed now is I have a plus and a minus. So how do I actually decide which of those is my inverse? Because there's only actually one answer for this. There is not actually 2 answers, but there's actually one answer for the specific inverse that I'm looking at. And the way that I do this, and you can use the vertex or you can use the 3 minus 7. It doesn't really matter. Think about what an inverse is. It means if I put minus 7 into the function, I should get 3. A normal function, we go from input to output. An inverse function, we go from output to input. So in order to check this, we're going to pop in when x is equal to minus 7. And we pop this in. So we have then y is equal to 4 plus minus square root of minus 7 plus 9 over 2. That then gives us 4 plus minus 2 divided by 2 is 1. Square root of 1 is just 1. So we have 4 plus minus 1. Now we want to get to the input, which is 3. So we want 3 in this case. So which of these answers gives me 3? Well, I need to have a minus. Yeah, because 4 minus 1 is equal to 3. So our actual inverse function here is the negative here, not the positive. So to write our final answer here, and you can write this straight away if you recognize this, 4 minus the square root of x plus 9 over 2. So I do like these paper 1 style questions on functions. They're really just testing your understanding, not just rote learning, but also, okay, how does this feed into the idea of domain and range, input and output? Question D, however, is a bit more standard. So the function g is defined by g of x is equal to 2x plus 4. The x is less than minus 1. And we need to find this composite function. Let me just write down the original function. So f of x is equal to 2x squared minus 16x plus 23. Again, as soon as we have a composite function, we're working from right to left. So we're working out f of g of x here. Well, g of x is equal to 2x plus 4. So we replace this g of x here with 2x plus 4. And then we put this into the initial function. Wherever I see an x, so let me get the highlighter out here. Wherever I see an x in this equation, I'm going to replace it with this entire 2x plus 4. So we get 2 then, 2x plus 4, all squared minus 16 brackets 2x plus 4. You can substitute it into the vertex form as well, that's also fine. Now I'm going to speed through a bit of algebra here, so just to remind you what this looks like, this is 2x plus 4 times 2x plus 4. This gives me minus 32x minus 64 plus 23. If we multiply this out, we get 4x squared plus, I know I'm speeding through this. This is just an algebra exercise for you. 8x is 16x, that's also 16 minus 32x minus 64 plus 23. That gives us then 8x squared plus 32x plus 32. We'll get a cancellation here with the x's, that's great. So this cancels here, this cancels here. And then we get, let's have a think about this. So 8x squared stays the same. 32 minus 64 is minus 32 plus the 23. That's going to give us minus 9 for our 2 marks. Okay, so you can have a look through the mark scheme. You can see where it picks up. One thing I haven't really talked about in many of my videos, I don't think, is the notation you can use. Now I use this y is greater than minus 7. Again, much more of an A-level style notation. But of course you could write f of x is greater than minus 7. IB, probably see that more. You can also use the bracket notation, which if you work in a German system, you see this quite often. So minus 7 brackets infinity with the brackets indicating it's strictly less than or strictly more than. So that's a useful thing to know. Again, they will allow all these notations because they just want to check you have the mathematical understanding about functions. Okay, and on to a similar style question, so question 8, so reasonably on the tricky side. Again, some twists, but still the same sort of fundamental question. So the first thing we need to do here, again, is we need to complete the square. You can see how that's an important part of the functions section. Notice we've got a negative instead, but we still treat it in exactly the same way. So if we take this, so let's take this expression here, minus 3x squared plus 12x plus 2. We're going to take, again, a factor, this time of minus 3 out. Again, we want that positive x squared at the start. So that gives us then x squared. Now, let's be slightly careful with negative numbers here. So here we're going to need a minus 4x. Notice we can always work backwards. Minus 4x times minus 3 gives me plus 12x. And the same idea here as well. We're going to go minus 2/3 because minus 2/3 times minus 3. Minus times a minus is a positive. The 3's cancel, giving me plus 2. So let's be very careful in negatives as we do this process. That's why I've included this question in the video. Now from here we do our standard thing, which we look at the b term, divide it by 2. So that's going to give us then x minus 2 all squared. Let's consider what it looks like when we multiply this out normally, and you can do this mentally as well, which gives us the first two terms as we want, but not the last one. Minus 2 times minus 2 is positive 4. So to get this last term, we need to do minus 4, then include this term in, minus 2/3. Then we're going to use that little trick we saw before. Minus 4 is the same as minus 12 over 3 to get that common denominator, which is important. So we get x minus 2 all squared minus 12 over 3 minus 2 over 3. Careful with negatives again. Remember, if you're minusing those fractions, that's going to give you minus 14 over 3. And then we do what we did in the previous question, which you just multiply back through. This then gives us minus 3 x minus 2 all squared. And then minus times a minus is a positive. Be careful. 3's cancel, giving us plus 14, which is, again, very similar process to the previous question, but again, we've got that negative, so we have to be a little bit more careful. We can also think about the vertex here as well. So the vertex would simply be just 2 and 14. So keep that in mind as we go through the question. Right, the one-to-one function, so one-to-one function f, is defined by, don't be confused by this notation, this just means f of x here, equals minus 3x squared plus 12x plus 2, so what we just had, for x is less than or equal to k, and state the largest possible value of the constant k. Well, I kind of talked about this in the previous question. The vertex, by using this, you have to use it in some way, it kind of leads on, is 214. So that's a maximum point here because we have a negative quadratic. Let's pop that in. So because it's the largest possible value that we're looking for, we just read off the x coordinate here. So we just put in then k is equal to 2. One mark question, it shouldn't be anything too complicated, but you do need to think it through carefully. Now we're actually given that k is not 2, but it's equal to minus 1. State the range of the function. But we can do something very similar to what we did in the previous question. First of all, I'm going to look at what f minus 1 actually gives me. So let's pop that in. So again, more negatives in this question, so you just have to really pay attention to what's going on. Minus 1 all squared, be careful, is 1. So we get 1 times minus 3 is minus 3, minus 12 plus 2. That's going to give us minus 13. Okay, so we know that one more point on our quadratic is also minus 1 minus 13. So if I was to draw a sketch of this, again, it's always useful to do a sketch here just to see what's going on. We have our maximum point at 214, so 2 along, 14 upwards, so somewhere like this. And then we've got our next term here of minus 1 minus 13. So it's going to be right down here somewhere. So again, 3x squared makes sense. It's going to be a very steep quadratic. Minus 13. And again, we're going to get this kind of shape here. Again, this is not to scale by any means, but it's just to give us an idea of what's going on with the function. And what they're considering here is state the range of f. So we've got x is less than or equal to minus 1. So if we take this point here, we essentially want everything less than that. So we want to go in that particular direction. Okay, what does that mean from a y perspective? We want everything from minus 13 and less than that. So our final answer here for the range from our diagram here, simply y is less than or equal to, be careful, because we've got a less than or equal in the question. Lots of little tricks you have to watch out for, is less than or equal to minus 13. Now we've got the inverse function again. We're going to have to be very careful because we have a quadratic to work with. So we copy across our completing the square version first of all, which gives us minus 3x minus 2 squared, and double check, plus 14 when you're copying over from one side to another. And we go through our three-step procedure here. So y is equal to the function, You should be very used to this from this video. It's why we do these videos, to really go through the fundamental concepts that you need to succeed on this paper. Then we've got step 2. So we're going to swap over the x's and y's, like so. I tend to flip at this point as well. Actually, I think I won't in this case. So what I'm going to do to avoid negatives, I'm going to add this on both sides. So I'll get x plus 3 y minus 2 all squared is equal to 14, then minus through dx. I'm a person that tries to avoid negatives at all costs. 14 minus x, then we divide through by 3. You can always times top and bottom a fraction by minus 1 to have the same effect. Then we square root, remembering we have a positive and negative. That's very important for later, as we've seen already. And then we add on 2. So we get y is equal to 2 plus minus 14 minus x over 3. Okay, if that was a little bit on the fast side, do look at the previous example that I went through a little bit more slowly. Now here again we've got two choices. It could be a positive or a negative here. Again, we use a coordinate we've already seen. So again, we can use a vertex. That seems a fine thing to use. So we want to work the other way around. So when x is equal to 14, we want y to be equal to 2. Because that's the definition of the inverse. Inputs become outputs, outputs become inputs. So if we pop this in, then we're going to get y is equal to 2 plus minus 14 minus 14 over 3. So that gives us then 2 plus minus, it's going to give us the square root of 0, which is just 0. So that gives us equal y is equal to 2. I wonder if we can use a different coordinate to check. So we could also use what we've done here, so minus 1 minus 13. So when x is equal to minus 1, or the other way around, minus 13, y is equal to minus 1. So let's check that as well to be on the safe side. So what do we get here? 14 minus minus 13 over 3. Yeah, this seems a more sensible one to check here, because we are going to get some different answers. We get 27 divided by 3, that's equal to 9. Okay, so this is an important one to check here. So we get 2 plus minus 3. We want negative 1 here, and we need the negative in order to do that. So our final answer, which I'm running out a little bit of space here, so I'll write it in here, is the inverse function is equal to when it's negative. Just to point out here, it's not always negative. You can't just put minus and forget about it. You do need to check through a coordinate. Again, using the vertex, you've got that symmetry idea, which means the square root disappears. But if you check a different coordinate from the function, then you'll find something you can work with, and therefore check if this is a positive or a negative. Okay, and on to a little twisty question at the end. So the result of translating the graph of y equals f of x by minus 3, 1 is the graph of y equals g of x. Express g of x in this particular form. Okay, now we've seen some questions like this on the iGCSE course. They do this as well, combining some transformations of graphs in here as well. So if we take the vector minus 3, 1, what this means in words is that we go 3 to the left and 1 upwards. I'm getting ahead of myself. 3 to the left and 1 up. Now if we write this in transformation language, this would be the same as going f of x plus 3 does the opposite of what you expect when it's inside the bracket. So you think you go 3 to the right, but because inside the bracket it goes 3 to the left. And here this is going to be f of x plus 1, because when the plus 1's outside the bracket, it works as you expect. So plus 1 because it goes 1 upwards. So what we want to do here, if we want to find g of x, we need to combine this together. So we need to work out f of x plus 3 and then add 1 to the function. This is another way of saying 3 to the left and 1 upwards. Now if we copy out our f of x function, Again, we can take either form. I think I'll take the original form, minus 3x squared. I'm not sure which one's quicker, but this seems the one to choose here. So what we do is wherever we see an x, we're going to put an x plus 3, and we're going to add on a 1 at the end. So we get then minus 3x plus 3 all squared plus 12 lots of x plus 3 plus 2 plus 1. Now we're going to do a little bit of expansion here. So here we get x squared plus 6x plus 9. Expand this bracket, 12x plus 36 plus 3. Expand this out, we get minus 3x squared minus 18x minus 27. No such easy simplification this time. So we have a minus 3x squared here. Minus 18x plus 12x is minus 6x. And minus 27 plus 39 is equal to 12. And we've got it in the form that they want, so P, Q, and R. Again, you could write very clearly for the examiner, P is minus 3. I'd always recommend this. Gives them no excuse not to give you all 3 marks. Yeah? And R is equal to 12 to give us our answer. So nice little twist. I did do a question similar to this in my iGCSE functions video, but it can appear on the A-Level Maths Paper 1 as well. Okay, so this is the answers for 8A and 8B that you see in front of you. And then we've got 8C and 8D. Again, you've got an alternative method. It's not like the way I approached question 8D. And then finally, we have question 8E here as well. And you can check the working that I've done using some transformations of graphs that I haven't done a video on just yet, but I'm sure I will be catching that up in due course. Now, if you need to practice everything that you need to know about radian measure, about using r theta, half r squared theta, to work out perimeters and areas of various shapes, well, that just seems totally confusing what I've just said, then check out the video right in front of you. I spend a good 40-50 minutes going through the topics you need to know to do really well on the A-Level Maths Paper 1.